Okay, another example with implicit differentiation. One big thing that we're going to look at here is how there are multiple instances of dy dx. Okay, so again, our task given the curve, find dy dx. We've got our steps here, and we see that our curve is y cubed plus 3x minus 4y squared is equal to x squared. Okay, so we're going to derive each term individually. So let's go ahead and do that. Y cubed, all right, we know we've done a couple of these now. Derive y terms like x terms, but because we're doing the chain rule, we're going to multiply by dy dx. Okay, so y cubed, derivative of y cubed, just like derivative of x cubed. X cubed derives to 3x squared, so y cubed will derive to 3y squared. Okay, but then we need dy dx at the end. Very important that we have that dy dx there, okay, because we are deriving a y term with respect to x. This is the symbol of the derivative of y with respect to x. It needs to be there. Okay. It also helps because that's what we're trying to find. So if we don't put that into our answer, then how can we find it? Next term, 3x. That's an easy derivative, plus 3. Okay. Term after that, minus 4y squared. Think of that like 4x squared. 4x squared's derivative? Yeah, 8x. So 4y squared will be 8y. But again, we need the dy dx. Okay? And then that's equal to, over on the other side, we have the derivative of x squared, which will be 2x. Okay, so we've derived all the x terms as usual, derived the y terms like the x terms. We derived each term. Our goal is to isolate dy dx. Okay? Well, we have dy dx here and here. So how do we get dy dx all by itself if there's two versions of it? Well, the key is to factor dy dx out of the terms, okay? Because then you'll go from two instances of dy dx to just one instance of dy dx, okay? But we cannot factor dy dx out of these two terms yet because we have a term in between that does not have dy dx. So we need to get rid of that. We need to move that over to the other side, and then we can do our factorization. So we're going to eliminate. Let me change over to red real quick. We're going to subtract 3 from both sides, okay? And in doing so, that means that we now have 3y squared dy dx minus 8y dy dx is equal to 2x minus 3, okay? We've done a little isolation here. dy dx terms on one side, non-dy dx terms on the other side. Okay, it's like a middle school dance. Boys on one side, girls on the other. That's exactly what's happening here. dy dx is on one side, non-dy dx is on the other. Okay, so dy dx here and here, that's a common term. All right, these two terms also have a y in common. We're not going to factor that out. I know we could, but ultimately our goal is to get dy dx out by itself, so we only want to factor the dy dx out. You'll see why more in a second. dy dx, we're going to factor it out. Okay, and you know from factorization in previous years that when we factor an item out, we're dividing it out from both sides. So 3y squared dy dx divided by dy dx will leave us with just 3y squared minus, and then 8y dy dx divided by dy dx leaves us with just 8y. Okay, notice how there were two instances of dy dx before, now there's only one. That's good. That's what we're trying to isolate. So we're in great shape here. Over on the other side, we still have 2x minus 3. Now we need to get dy dx all by itself. How do we do that? Yeah, we're going to divide. We have dy dx times this expression, so let's divide by the expression. And if we do so, that will eliminate the expression on the left side. But if we divide by 3y squared minus 8y on one side, yeah, we got to do it on the other as well. Okay? What are we left with on the left side? dy dx. Good. All right, that's our goal, is to find dy dx, to isolate it. Okay, and we've done that. What's on the other side? Well, we've got this expression, 2x minus 3 over 3y squared minus 8y. And that's it. We've done it. We're done. Let me get my hand out of the way. There we go.